In today's video, we're going to be talking about Physics 252, Week 3, Problem 4. In this problem, we are asked to figure out how the velocities of stars depend on their distance from the galactic center when the galaxy is surrounded in a sphere of dark matter. So I thought this problem was really cool in that it uses a lot of Newton's equations for gravitation, and it's just kind of a cool physics concept to be looking at. So let's get into the problem. I've gone ahead and underlined some things that I think are important as we go through the problem. Mostly that the galaxy is dark matter dominated, and it's a solid sphere of uniform density right here. So this is really important because it pretty much says that we can assume we can make some pretty good assumptions about equations relating this sphere to the density here. So as I was saying, we have to kind of find an equation to relate velocity to distance from the galactic center. So in my drawing here, what I've done is I've defined this small r here as the radius of our galactic center. Let's just say these are maybe some stars on the outskirts, but it's maybe something like this. And this big R here delineates the radius of the dark matter sphere. So this is just saying that the radius of the dark matter sphere is much greater, and this small mass m should actually be more galaxy mass. But we also have our dark matter density here, rho. So some of the equations that are going to be useful, the most important of which is Newton's law of universal gravitation, using the gravitational constant here, g, as defined here. And the equation for a sphere is actually going to be really important for this one. So what we can do is, since we're given rho here, and we're assuming that the dark matter mass is much greater, we can assign it the greater value m, uppercase m, and we can define our galaxy mass as lowercase m. So kind of getting into the equation here, what I've done is I've kind of reorganized our equation here with our variables. So we have our uppercase m and our lowercase m. And then what I've done here is I've said that, okay, mass divided by rho is equal to volume. So if we say that our volume of the sphere is given by this equation, we can set the two equal to each other and solve for m in order to kind of get this out of the equation here. So that's what I've done. I've gone ahead and substitute uppercase m for uppercase m in this equation. And after a little simplification, we're left with this right here. And this is actually pretty interesting because this tells us that given that the dark matter sphere is of uniform mass, or uniform density rather, that the force due to gravitation is actually linear as you move away from the center of the galaxy, which is pretty cool. So what I've done now is I've decided to set this equal to the force, centripetal force here. I figured this would be a good thing to get it in terms of velocity, as well as the fact that as the stars are rotating, they're being drawn. So this is also used in I think other equations of Newton's, the force due to centripetal force, excuse me. So I've set them equal to each other here, and just solving for v, we're left with this equation here, which I thought was pretty interesting. You know, I wasn't quite sure about having the square root of the gravitational constant at first, but I think in this form it looks pretty all right. So I hope you guys found this video helpful, and thank you very much for watching.